So the first set of critical points is when we got it equal. The next set of critical points are, that's not what I want to say. So find whatever makes the problem undefined. And you did this 2 times ago when you found all the vertical asymptotes. So remember when you found the vertical asymptotes, those are the things that made the problem undefined. Well, that's the same thing. We use those points as critical points. So whatever makes the denominator equal to 0 will be another critical value. So those will be our critical points. So what we do with those critical points after that is we create a chart. So we're going to have our number line, and these will be our critical points. So when we create our number line, it's broken into sections, and those sections are all from our critical points. And then we take from those critical points, we take test numbers. So any number in these regions are our test numbers. So we're going to take our test numbers and plug them back into the original equation and find out if it worked. So we'll create our chart with our critical points. We choose test numbers. You can choose any number you want from within that region. So I always try to use the smallest numbers that I can. And once we have our test numbers, plug our test numbers back into the original equation. So that's the whole idea of today. So this is only when there's inequalities. So we'll do a bunch of these together because that's the easiest way for me to help you understand what's happening. So number 21, I haven't figured out what all your assignment is yet, but these ones were going to be part of it. So on 21, it has 4w squared minus 9 is greater than or equal to 0. So the first thing we need to do is find our critical values, critical numbers. So we solve this as though it were an equal sign. So we do it exactly the same as though it's an equal sign. And so now to solve that, you could factor, or you could add the 9 over to the other side and have 4w squared equals 9. And then divide it by 4. So w squared equals 9/4. And then to get rid of the squared, square root. So you get w equals plus or minus the square root of 9 is 3, the square root of 4 is 2. If you would have factored, it would have looked like this: 2w minus 3, 2w plus 3. So whatever way you would have wanted to do it, you could have, either way is fine. So these are my critical numbers. So now I draw a number line. Negative 3/2 is over here, 3/2 is here. So what's a number to the left of negative 3/2? Like negative 2. In between negative 3/2 and 3/2, I like to use 0 whenever possible because it's easy to work with. And greater than 3/2 is 2. So now these are my test numbers. I plug those back into the original problem. So when I plug in negative 2, 2 times 2 is 4, times the 4 out here is 16, minus 9 is 7. Is that greater than or equal to 0? The answer is yes. I plug 0 in. 0 minus 9 is negative 9. That's not. And when I plug 2 in, it's going to be the same thing because negative 2 squared made 4. 2 squared makes 4. So that's also going to be greater than 0. So all the numbers that will work to make this greater than or equal to 0 is this interval. So negative infinity to negative 3/2. And because it can equal, it's a bracket. If it would have been just greater than or less than, it would have been a parenthesis. Union, this one, 3/2 to infinity. So these are my locations that it worked. So anything in between these numbers would give me a value that's greater than or equal to 0. I thought I'd do the evens with you so that when I assign some of it, you can have the odds. So on 24, same thing when we're doing it with equal sign, we want it to equal 0. So I'm going to distribute this 3 to both of those pieces. I should probably give you a minute to write it down. So again, the first step is to make sure you put it to equal and solve it just like it's an equal problem. So I'm going to minus the 3y and minus the 12. So I minus the 3y minus the 12. And we get 5y squared plus 4y minus 12 equals 0. And hopefully that factors. 5y and y multiplies to be negative 12, adds to be 4. 2 and 6, 2 times 5 makes 10, minus 6 makes 4. So that works. So plus 2 and minus 6. So 5 times 2 is 10. Minus 6 makes 4. So those are my factors. You could have used the little square box method thing. 5y squared, negative 12, that makes negative 60y squared. So what multiplies to be negative 60 and adds to be positive 4, that would be 10 and 6. And so you'd put those in here. 10, negative 6. Then you'd have the 5y, 1y, 2. So anyways, that's a little square if you wanted to do that way, that box method, to refresh your brain. So now you solve each of these and you get y equals negative 2. And this one would add the 6 over to the other side and divide it by 5. So 5y minus 6 equals 0. You'd add the 6 and divide it by 5. So those are our critical values. So we've done all this work. It's the same thing as what you have been doing, but now we've added another, not step, but steps to it. So now we're going to choose, so those are our critical values. Now we choose test numbers. So something less than negative 2 would be negative 3. Between negative 2 and 6/5 would be 0. Greater than 6/5 would be 2. So now I plug those back into my original problem. So negative 3 squared is 9, times 5 is 45, minus 21, 7 times negative 3 is 21. So 45 minus 21 is 24. Is that less than negative 3 plus 4 is 1 times 3? Is 24 less than 3? So that didn't work. So now I plug 0 in. I really like 0. So 0 goes that side 0. Is that less than 3 times 0 plus 4? So that's 12. 3 times 4 is 12. So 0 is less than 12. Normally if it works in the middle, it doesn't work on these ones. It doesn't work on the next one to it, normally. There are a few instances where it does, but for the most part it doesn't. So now we're going to plug 2 in. 2 squared is 4 times 5 is 20 plus 7 times 2 is 14, so that's 34. Is that less than 2 plus 4, which is 6 times 3 is 18? So it's 34 less than 18. No, so that didn't work. So notice this is just a less than. So the only place that makes it less than is between -2 and 6/5. And because it was not an equal to, we use parentheses, not the brackets. So that's the only interval where I can have x values that, or y, whatever this variable is, they'll make it less, the left side less than the right side. So the first thing you want to do is make it equal to 0, right? Now here's your thought process. How do we get anything divided by something to be 0? What divided by stuff is 0? Yeah, so the top has to be 0. Does it matter what the bottom is? As long as you have 0 on the top, you can have whatever you want on the bottom, right? So all you have to do is figure out what makes the numerator equal to 0. So you add the x over here, and x equals 5. So that's one critical value. Do you remember how we get the other critical value? There were two parts to get critical value. The first one was make it equal to 0. The second one is whatever makes the bottom go to 0. That's our other critical value, is what makes it undefined. So minus the 1, so x equals -1. So those are my two critical values. So when I do my number line, we're going to have -1 and 5. And it can never equal -1, so that will always be a parenthesis. Like this, because it's a critical, like that's the 0 on the bottom, that's what makes it undefined. It can never equal that. That will always be a parenthesis on that part when we get our final answer. So now we just plug in some test numbers. So less than -1 is -2. Between -1 and 5, because we can, let's use 0. And greater than 5 is 6. So I plug those in. 5 minus a -2 and -2 plus 1. So 5 minus a -2 makes 7. -2 plus 1 makes -1. So is -7 greater than 0? So that area is gone. I plug 0 in. 5 over 1. Is that greater than 0? So that's good. So when it has a denominator, when we have a fraction, that's more likely that you'll get 2 in a row that work versus when we had the other. So now we're going to plug 6 in. 5 minus 6 is -1. 6 plus 1 on the bottom is 7. Is that greater than? It's a negative number, so that can't be bigger than 0. So the only place that worked was between -1 and 5. The -1 is a parenthesis, and because it's greater than or equal to, it can be equal to 0, so 5 is a bracket. Now for the last one.
So if -1 hadn't been something that made it go to undefined,
it could have been a bracket as well. Yeah, but since it was made it go to undefined, you know that it can't ever equal that. So on this one, our critical values, we can get the denominator one first if you want. P minus 1 equals 0. That would mean that P equals 1. That's one critical value. And so now to get the other one, we take the top and we make the top equal to 0. And then we hope that it factors, which it does. P plus 4 and P minus 2, because 4 times -2 is -8. 4 minus, I got my signs backwards, because 4 minus 2 is +2. So that means to be a -4 and a +2. So now that I've got it factored, I can put each factor equal to 0. So I know that p equals 4 and p equals negative 2. Because I would have put those equal to 0 and solved each one. So p minus 4, add the 4 over, p equals 4. And then I would have done the same with the p plus 2.
On this one, 3 critical points?
Correct. So there are 3 critical points on this one. So negative 2, 1, and 4. Make sure you put these in order, or else it really doesn't work very well. So a value to the left of negative 2 for a test number, between negative 2 and 1, between 1 and 4, 2, and greater than 4, 5. So you've got to do this 4 times. So negative 3 squared is 9. Negative 2 times negative 3 is 6. So 9 plus 6 is 15, minus 8 is 7. And then on the bottom we have negative 3 minus 1 is negative 4. So is a negative number greater than 0? So that can't work. I plug 0 in, I get negative 8 over negative 1. A negative divided by a negative, positive, so 8 is greater than 0. So that area worked. So now I plug 2 in. 2 squared is 4. 2 times 2 is 4, so 4 minus 4 is 0. Minus 8 is negative 8. And then 2 minus 1 on the bottom is 1, so I get negative 8. So that's not greater than 0. So that area didn't work. So now I have to plug 5 in. 5 squared is 25. 2 times 5 is 10. Minus 8. So 25 minus 18 is 7. And then 5 minus 1 is 4. So 7/4 is greater than 0, so this area worked. So now I look at this. The one that it could not be was 1, right? So that's going to be a parenthesis on the 1. Bracket on negative 2 because it's a greater than or equal to. If it would have just been greater than, it would have been a parenthesis. But because it's an equal to, it will be a bracket. So from negative 2 to 1, along with 4 to infinity. And 4 is going to be a bracket as well. So the ones, your critical values that you find from setting the top equal to 0 will either be a bracket or parenthesis based on your sign. The critical value from the denominator, what makes it go undefined, will always be a parenthesis. So on this one, there's going to be 2 critical values for the denominator that make it undefined. So this one, I add the x over and I get that x equals 4. And on this one, I add the x over and I get that x equals 1. So now I'm going to make it equal to. So do you remember how to do a problem if you have a fraction equals a fraction? You can cross multiply. Here's a quick example. Like 2/5 doesn't necessarily equal 4 over 10. Like the ratio is the same, but when you cross multiply, 2 times 10 is 20, and 4 times 5 is also 20. So anyways, so now that we have it here, we're going to cross multiply. So we're going to go 6 times 4 minus x. So that was this way. And then we're going to cross multiply that one. 3 equals 1 minus x. So now I just distribute. 6 times 4 is 24 minus 6x. 3 times 1 is 3 minus 3x. So I'm going to add the 6x over here and minus the 3 to over here. So I get 21 equals 3x. Divide it by 3, so x equals 7. So I now have my critical numbers. We draw a number line. 1, 4, and 7. So you'll always draw a number line with your critical values. Put them on here. So again, I should have chose one that wasn't a greater than or equal to or less than or equal to, just so that we could have seen. But I know with 4 and 1, those are both going to be parentheses, right? When I do my answer, because those are my values that would make it undefined. 7 will be a bracket, because this is an equal to on the bottom of it. So when I get to my final answers, that's what I'll have. So test numbers less than 1, 0, between 1 and 4, 2, between 4 and 7, and greater than 7. You want to use 10? I could use 10. I put 8 down, but you could use 10. You could use 100 if you wanted to. So, yeah, you can. You said 10. So now I plug these in. 4 minus 0 is 4, right? So I have 3/4. Is that less than 6 over 1? Yeah, so this one worked. So now I plug 2 in. 4 minus 2 is 2, so I have 3/2. Is that less than? I plug 2 in for x. 1 minus 2 is negative 1. So that makes negative 6. A positive number can't be less than a negative number. So that doesn't work. Now I plug 5 in. 4 minus 5 is negative 1. So that's negative 3. 1 minus 5 is negative 4. So which one's further left, negative 3 or negative 6/4? So negative 3 is further left, which means it is less than. So that one. And now we have 10 to plug in. 4 minus 10 is 6. So 3 over negative 6, which makes negative 1/2. And then 1 minus 10, which makes negative 9. So that's negative 2/3. Which one's further left, negative 1/2 or negative 2/3? So negative 1/2 is not less than that. So my answer is from negative infinity to 1, along with 4 to 7. So make sure when you write your little answers in the bracket notation, interval notation is what they call it, do you use the critical numbers, not the test numbers, to make your intervals? I've done that before. I'm cruising along in a hurry and I'd write down these numbers and then I'm like, whoa. So anyways, make sure you use these bottom ones. Okay. So we'll have the quizzes due Monday morning. So 93 and 97 will be bonus. You ought to look at them so that when I go to cover them, you'll at least see what they are.